This exercise related to atomic structure, that was the last week homework. In the beginning of exercise, you can see the learning objective of the syllabus. Better to go through these learning objective first before you start, and then the summary is there uh, related to the topic. The key points. The question starts from page 5. The graph shows a sketch of the first six or first ionization energies of the 6 successive elements. The letters are not the symbol. What is meant by the first ionization energy? So how we define the ionization energy is actually energy required to remove the electron from a neutral gaseous atom. Like if we remove the electron from a gaseous atom, the energy which we need, we call that as ionization energy. Because it's the first ionization energy, so energy required to remove electron from the neutral gaseous atom. If it was a second ionization energy, then energy required to remove electron from a gaseous ion of charge +1. Now, we can also, as we know, what is a general trend in ionization, and these are the successive elements, okay? So we know group 8 will have the highest ionization energy. So means this should be group 8. So after group 8, again we'll have group 1 because these are the successive elements. Like we have group 1 element, then we have group 2 element, then we have group 3, group 4, group 5, group 6, group 7, and then we have group 8. So once we have group 8, then again we'll have a group 1 element. So means this will be group 1 element, this will be group 2 element, this will be group 3, group 4, and then group 5. So usually when we move across the period, ionization energy increases. But why group 2 and group 3? There is a difference. If you remember the shielding effect, between 2 and 3, the effect is a shielding effect. And if there was group 6 as well, if it will be here. And why group 6 will have a lower ionization energy than group 5? Because that is a pairing of electrons. Electrons occupy the orbital, the p orbital singly. So they will have less repulsion as compared to a pair of electron in the orbital. Suggests why the first ionization of a B is much less than A. And it's of 3 marks. So how you can score the 3 marks? First thing, because these are the successive ionization, successive elements are there. So it means, like if we say A is here, so B will be here. Means B will be another period. Then C, D, E, and then F. So when we compare A with B, one thing, this A is in like the higher period, lower period, like maybe the second period, but B is the third period. So if the periods are different, the size will be different. So A will be smaller in size, and B, because it belongs to another period, so B will be larger in size. That is one reason. So when A will be smaller in size, the attraction of A, like it will have a greater attraction towards the nucleus. So as it has greater attraction towards the nucleus, so we need greater amount of energy. And another thing, B will have a greater shielding effect. Why? Shielding effect depends on number of inner shell electrons. Greater the number of the shells or orbitals, greater the shielding effect. So B is having a greater shielding effect, so lower ionization energy. So the 3 points you will mention. One thing, size of A is smaller than B. So electrons are closer to the nucleus, stronger attraction. The second thing, B is having greater number of electron shells, so it will have a greater shielding effect or less attraction towards the nucleus. So less energy is needed for B and more energy is needed for A. Is it clear? Any doubt in this? It is important that you summarize those points. There are more protons. There will be more protons in B as compared to that of A. So you cannot relate the proton, because as the proton number increase, the ionization energy should increase. But in this case, the ionization energy is not increasing, it is decreasing. So why it is decreasing? Because there are successive successive elements are there. So if this is having a proton number 10, this will have 11, this will have 12, this will have 13, 14, 15, any number, but these are successive elements. So the points you have to list here: A is smaller in size. So A is smaller in size compared to B. So strong electrons for A, electrons are closer to the nucleus. And there will be a greater attraction. Where for B, greater number of electron shells. So it will have a greater shielding effect. If it is having a greater shielding effect, so less energy is needed to remove electron. Where is electrons are closer, greater attraction, so we need more energy to remove electron. You cannot mention about protons. Why you cannot use the term proton here? Because B will have more proton than A. So if B is having more proton, then it should have a higher ionization energy, but B is having a lower ionization energy because the size of B is bigger than size of A. Is it clear now, this question? In question 2, from P to T are the successive elements of in the period 3 of the periodic table. Their letters are not the symbol. On the axis, sketch a graph to show the trend. So successive elements are there: P, Q, R, S, and T. So what will happen? Usually in the same group, the ionization energy will increase. Because the first one will have a lower ionization energy than the second. And here, what happened to the atomic radii, the size of the radius of an atom? So because it's about the atomic radii. So successive elements, as in the same period, the proton number increases. If the proton number increases, so the nuclear charge will also increase. So attraction will also increase. So if we say like this, if this was a size of P, then the size of the Q, then R, S, and T. Because it in the same period, so same period, the size will decrease. And what is the reason for this decrease in size? What are the points you should mention? You can also, because it's just a sketching a graph. No, I'm just giving an example. It's not like a bar graph. because this sketch is there. So you can sketch the graph. You can just draw a line to show that the size is decreasing. I was just giving an example. If you say term nuclear charge or the charge on the nucleus, they have the same meaning. No difference. The 3 points are there. What are the 3 points? Uh, they all have the same shielding effect. Why same shielding effect? Because they're in the same period. Approximately same shielding effect is there. The proton number increases across the period. So as a result, greater nuclear charge. So strong attraction, which reduce the size of atom. Is it clear? The next is, the questions are actually not in order of the, it's according to the order of the exam paper rather than the assignment. That's why you can see like question 1, then 2B, then, so it's not in that order. The table shows information about some elements, some of elements in the third period. Atomic radii, you can see atomic radii is decreasing. Radius of the most common ion. For positive ion, the ionic radii decreases, but for negative ion, the ionic radii increases because negative ions gain electrons, so attraction towards the nucleus decreases. That's why the size increases. Complete the table, maximum oxidation number. Look, oxidation number, the charge appeared. So group, this is group 2, so it will be +2. Group 3 will be +3. They're asking for maximum. Remember from IGCSE what we have discussed. If you remember the oxidation number is the charge appear on the atom when it form a compound. So these are the groups, the common oxidation number like group 1 +1, group 2 +2, group 3 +3, group 4 -4, -3, -2, -1, 0. But group 4 can also have +4. Group 5 can have +5 from any number from -3 to +5, from -2 to +6, and from -1 to +7. So these are the possible oxidation numbers are, but they're asking for the maximum oxidation. So what is the maximum for group 1, 2, 3? Like this is a maximum. But what about group 4? Group 4, no element. Group 5, phosphorus is there. So -3 to +5, it can have any oxidation number. But what is the maximum number? The highest number is +5. Then for group 6, the highest number will be +6. Because they asked for maximum. If they ask for minimum, then what we will write? If this was the same question and the question was the minimum oxidation number, it won't change for group 1, 2, 3, but it will change for group 5. So group 5 will be -3 and group 6 will be -2. If it was a minimum oxidation number. Then explained why atomic radii of element in the third period decreases. It's the same question as we did here about the size. So what is the reason why the size is decreasing as we move across the period? So the points we will mention that the proton number increases. They all have the same shielding effect. Proton number increases. So as the proton number increases, stronger attraction. As a result of a stronger attraction, the size will decrease. Is it clear or should I type? So same answer for this one. Then the radius of the most, how do they have the same shielding effect? there will be a small, for sodium to magnesium, there will be a small difference in the shielding effect, but rest all of them have the same shielding effect. Why? Because if we talk about the shells, the sodium, first shell, it will have 2 electrons. Second shell, it will have 8 electrons. The third shell, it will have 1 electron. Magnesium, in terms of orbital, there will be a small difference for magnesium and between magnesium and sodium, the shielding effect, but in terms of shell, they have the same shielding effect. First shell 2 electrons, second shell 8, third shell only 2 electrons. Then aluminium, first shell it will have 2. So across the period, the shielding effect remain the same except for group 1 and 2, because group 1, the orbitals are different as compared to that of group 2, like group 2 and 3 actually. So how the shielding effect is same, first shell 2 electron, second shell 8 electron, the third shell 1 electron. First shell 2 electron, second shell 8 electron, third shell 2 electrons. For aluminium, first shell 2 electron, second shell 8 electron, and the third shell 3 electron. So how they have the same shielding effect? Shielding effect means how many inner shell electrons are there. So how many inner shell electron for sodium? 10, for magnesium 10, for aluminium 10. So they all have the same inner shell electron. They all have the same inner shell electron. That's why they all have the same shielding effect. But why the size is decreasing? Because here the same shell, the third shell, but 11 protons are pulling them. In magnesium, 12 protons are pulling them. In aluminium, 13 protons are pulling them. So 13 proton exert more force than 12 proton, and 12 proton exert more force than 11. That's why as we move across, the size of an atom will decrease. That's why the size is decreasing. You can see here. So across the period, the size decreases because they have the same shielding effect and there are more protons, so stronger attraction towards the valence shell. Magnesium of the radius of the most common ion of a magnesium is much smaller than sulfur. Identify both ions. So what is the ion for the magnesium as it belongs to group 2? So magnesium ion will be Mg plus 2. And what is the common ion for sulfur? It belongs to group 6, so it will be minus 2. But why the size is different? If you see about the magnesium, magnesium is having 12 protons, okay? Then first shell 2 electrons, second shell 8 electrons, third shell 2 electrons. So it will be 2, 8, 2. But when we draw the magnesium ion, the same 12 protons but 10 electrons, because magnesium is losing electrons. So magnesium ion will have 10 electrons. And another thing, the shell also, like before the 12 protons were attracting the electron from the third shell, but now the 12 protons are attracting the electron from the second shell. So there will be like the shell, the number of the shell also decreases and there are more protons than electrons. So as a result, the magnesium ion, the size of a magnesium ion will be smaller. But opposite will happen for a sulfur. Atomic number of a sulfur is 16. So first shell, it has 2 electrons. Second shell, it has 8 electrons. And the third shell, it has 6 electrons. When a sulfur atom turns into sulfur ion, the same 16 protons, now they have to attract what? Because it is gaining electron. So they have to attract 18 electrons now, like the total. Because It is an ion now, so it has more electron than proton. So here 16 protons are pulling 18 electrons. Here 12 protons are pulling 10 electrons. Plus the size, the shell, plus the number of the shell also changes. In case of magnesium, 2 shells are there, but in sulfur, there are 3 shells. So why the magnesium ion is smaller? Because it has 2 shells as compared to that of a sulfur ion, which is having 3 shells. Is it clear why the magnesium ion is smaller than the sulfur ion? Any doubt in this? Any question or doubt in this? How you will write? First thing you will mention because it's of 2 marks. 1 mark is for mentioning those ions, like magnesium will form a magnesium plus 2 ion, and sulfur will form a sulfide ion, and magnesium is having 2 electron shell. Where sulfur contain 3 electron shells. That's why magnesium is smaller as compared to that of sulfur. Or magnesium ion is smaller than sulfur. The next is a naturally occurring sample of cerium contain 4 isotopes. Data for 3 of the isotopes are shown. And the relative atomic mass is given. Use these data to calculate the relative isotopic mass. Look, how to get the percentage abundance? The total sum of all the isotope, it should be 100. So if we add, like example, we add 0.85, we have 0.815, sorry, 185 plus 0.251 plus 88.45, and then subtract from 100, we get 11.11. So this 11.114, because the total sum of all the percentage abundance of each isotope, when we add them, we should get 100. So when we subtract from all this from 100, what we get? We get 11.114. That we got. Now, the relative atomic mass, the average atomic mass or isotopic mass is equals to percentage of the isotope multiplied by its mass. So what is the percentage? 0.185 multiplied by its mass, which is 135.907, plus the percentage of the isotope, which is 0.251 multiplied by its mass, which is 137.906, plus the percentage of the isotope, 88.45, 0, and multiplied by its mass, so 139.905, plus the percentage 11.114 multiplied by its mass, which is x, we don't know, and total divided by the sum, so which is 100. And the average mass is already given to us, the mass of the sample, so this will be 140.116. So what we simply have to do, we have to solve for x, like multiply this, then multiply the, add them. This 100 will be multiplied there, and this whole sum will be subtracted from the other side, and then at the last divided by 11.114. So that will give you the mass of the relative isotopic mass of this 142. Is it clear? Or should I solve the steps as well? Just a mathematical calculation you have to solve for x. The next we have the composition of atoms and ions can be determined from a knowledge of atomic number, the nucleon number, and the charge. Atomic number is 3. Atomic number also shows the number of the protons. The number of proton will be 3. Nucleon number, it's written here 6. So nucleon number is 6. Nucleon number is the sum of neutron and protons. If their nucleon number is 6 and 3 protons are there, so how many neutrons should be there? So it should have 3 neutrons. Then if proton number is 26, atomic number will be 26. And you have to check the periodic table, which element in the periodic table is having atomic number 26. So when you check the periodic table, it will be iron, Fe, and atomic number is 26. What about the nucleon number, the sum? So 32 plus 26. So when you add 32 plus 26, it will give 58. So the nucleon number 58, here also we write 58. Is it a charge or uncharged? How to identify? 23 new electrons are there and 26 protons. So 3 extra protons are there. So it means it will be a charge 3 plus or plus 3. Next. Boron occur naturally as a mixture of the two stable isotopes. The relative isotopic mass and the percentage abundances are shown. Define the term relative isotopic mass. You have to learn the standard definition. So relative isotopic mass is a mass of an isotope or mass of an atom, you can also say, because it's about isotope. So you can say mass of an isotope, which is compared with the 12th part of carbon 12. So this is standard definition. You have to memorize this definition. So if it is an atomic mass, we'll write mass of an atom. But if it is isotopic mass, so it is a mass of isotope compared with the 12th part of carbon 12. So when we compare with the carbon 12, this is a standard definition. You have to learn this. The next is relative isotopic mass of boron 11. We need their abundances are given. So how it can be done? We can use the same idea like percentage of the isotope and in the beginning of the question, and give your answer to 6 significant figure. So this is unknown, X is there. So percentage of the isotope multiplied by its mass, percentage of isotope multiplied by mass. So if we say the average mass of the two isotopes, when we take, how we can work out the average mass of the isotope? And at the last, we'll calculate the relative isotopic mass. So if you want to calculate the average mass of the isotope, it's a percentage of the isotope multiplied by its mass. plus the percentage of the isotope multiplied by its mass, and then divided by 100. So first we'll find the average mass of these two isotopes, okay? And then we'll find the relative isotopic mass, like what is the actual mass is there. Now, the percentage of the isotope is given 10.0129. So we have 10.0129 multiplied by, like this is the mass of this isotope, and this one is the abundance is there, which is 19.78. First, directly if we take an average, like if I want to take a direct average of these two, first if I use this mass 10 and the percentage abundance, so this will be 10 and it will be 19.78 plus this mass is 11 multiplied by the percentage abundance, which is 80.22, and divided by 100. What's the answer for this? 19.78 multiplied by 10. I took the actual mass of the isotope to get an average. What's the answer for this? Ten times 19.78.
10.8022.
10.8022. Okay. So now we got an average. Okay. So the average mass of these two isotopes for boron 10 and boron 11 with these percentages, the average mass of this is 10.8. Now, first, what we are doing, because the formula is the average mass is equals to the percentage of the isotope multiplied by its mass plus the percentage of the isotope multiplied by its mass divided by 100. Now, this is 10.012 and this is to be calculated. Like this isotopic mass, actual number we have to calculate. But before we calculate this isotopic mass, we should know an average of these two. So if a boron is 10 and its percentage is 19.78, and if boron 11 is there, like if there were a whole number, like if we have a boron, actual boron 10 is there, it will not be complete, but average, and we have a boron 11. So what will be the average of these two masses? The average of the mass will be 10.8. That is the average mass of the two boron. Now, after finding the average mass of the two boron, now we take the actual, like relative isotopic masses. First, we took the whole number, the mass, like the total mass, which is also a nucleon number, and work out the average nucleon number. And then we substituted this average nucleon number like relative atomic mass, which we got 10.8. So 10.8 is equals to the percentage 10.0129. Like the mass of this isotope, now the actual mass of the isotope. First, we took the whole number 10 and 11, but now 10.012 multiplied by its percentage, 19.78 plus this mass we don't know, x, multiplied by its percentage, which is 80.22, and divided by 100. Now we simplify this for x. What's the answer? So first we took, because from the whole number, the masses of the nucleon number of the two isotopes and their percentages, first we find the average mass of the two. Then using those average mass, we find the actual mass of those isotopes. How to take an average mass? Example, we have boron 10 is there. In the question, isotope of a boron 10, isotopic mass is this, but the nucleon number is 10 with a percentage abundance of 19.78. Nucleon number is 11 with a percentage abundance of 80.4. So when you take an average, no, I did not use a periodic table. I took an average from this information. So this will be 10 times 19.78 plus 11 times 80.22 divided by 100. That will give an average mass. When percentages are given, we take an average by mass into percentage plus mass into percentage divided by 100. So that will give us an average mass of the two isotopes. And from the average mass of the two isotopes, we took the isotopic mass, which the same formula we use again, and now we substituted the isotopic mass and find the isotopic mass of another isotope of boron. Is it clear, this example?